Lesson: Evaluating and improving predictive models in supply chains. Evaluating and improving predictive models in supply chains is a critical aspect of enhancing operational efficiency and decision-making. Predictive models enable supply chain analysts to anticipate future events, optimize resources, and mitigate risks. However, the effectiveness of these models largely depends on their accuracy, reliability, and adaptability to changing conditions. This lesson delves into the methodologies for evaluating and improving predictive models, emphasizing actionable insights, practical tools, and frameworks. The first step in evaluating predictive models is to understand the key performance indicators relevant to the supply chain context. Common KPIs include forecast accuracy, lead time variability, inventory turnover, and service level. Forecast accuracy, for instance, is crucial as it directly impacts inventory levels and customer satisfaction. To measure forecast accuracy, metrics such as mean absolute error, mean absolute percentage error, and root mean squared error are often used. These metrics provide insights into how closely the model's predictions align with actual outcomes. Once the KPIs are defined, the next step is to validate the model using historical data. Backtesting, a process where the model's predictions are compared against previously observed data, is a common technique. This helps in identifying any systematic biases or inaccuracies in the model. Cross-validation, another critical method, involves partitioning data into subsets where some are used to train the model while others test it. This technique ensures the model's robustness and ability to generalize across different datasets. Improving predictive models often requires refining their algorithms and input features. Feature engineering, the process of selecting and transforming variables to improve model performance, is a crucial step. For example, in the context of demand forecasting, incorporating external factors such as economic indicators, weather patterns, and social media sentiment can significantly enhance prediction accuracy. Tools like Python's scikit-learn and R's caret package provide robust frameworks for feature selection and model training, enabling analysts to experiment with different variables and algorithms. Another essential consideration is the choice of predictive modeling techniques. Machine learning models such as random forest, gradient boosting machines, and neural networks have gained popularity due to their ability to handle complex, nonlinear relationships within data. These models, however, require careful tuning of hyperparameters to optimize performance. Grid search and random search are techniques used to automate hyperparameter tuning, ensuring that the model operates at its best. In practical terms, integrating these models into supply chain management systems involves using platforms like SAP Integrated Business Planning or Oracle's Demantra, which offer built-in predictive analytics capabilities. These platforms provide seamless integration with enterprise resource planning systems, allowing real-time data flow and decision-making. By leveraging these tools, companies can enhance their responsiveness to market changes and improve their overall supply chain performance. A case study exemplifying the application of predictive models in supply chains is the transformation undertaken by Amazon. By implementing advanced predictive analytics, Amazon can anticipate customer demand with high accuracy, enabling it to optimize inventory levels and reduce delivery times significantly. This capability has been a cornerstone of Amazon's logistics strategy, contributing to its reputation for reliability and customer satisfaction. Despite the advantages of predictive models, several challenges persist. Data quality is a significant concern, as inaccurate or incomplete data can lead to erroneous predictions. It is imperative to establish robust data governance frameworks to ensure data integrity and consistency. Additionally, the dynamic nature of supply chains necessitates that models are continually updated with new data and retrained to maintain their accuracy over time. Incorporating feedback mechanisms is another strategy for improving model performance. By analyzing model outcomes and discrepancies with actual results, supply chain analysts can identify areas for refinement. This iterative process is akin to the continuous improvement cycle in quality management, where feedback is used to enhance processes and outcomes incrementally. Moreover, the ethical implications of predictive analytics should not be overlooked. Transparency in modeling processes and the avoidance of biases are essential to ensure fair and equitable decision-making. Supply chain analysts must be vigilant in assessing the ethical considerations of their models, particularly in contexts where they impact employment or resource allocation. In conclusion, evaluating and improving predictive models in supply chains is a multifaceted process that requires a comprehensive understanding of metrics, validation techniques, and model refinement strategies. By leveraging practical tools and frameworks such as machine learning algorithms, feature engineering, and enterprise platforms, supply chain analysts can enhance the accuracy and reliability of their predictions. Case studies like Amazon's demonstrate the transformative potential of predictive analytics in supply chain management, emphasizing the importance of continuous improvement and ethical considerations. As supply chains become increasingly complex and interconnected, the ability to develop and refine predictive models will be a pivotal skill for professionals, enabling them to drive efficiency and innovation in their organizations.